In this video, we'll look at examples of using the multiplication, division, addition, and subtraction rules for square roots to simplify expressions. Let's start with reviewing the rules. The multiplication and division rules are very similar. The idea is that if you are multiplying two square roots together, you can change that into a square root of their product of the radicants. That's similar for the division rule. If you're dividing two square roots, you can make that into a single square root of the fraction that was involved originally. So what we have here, for example, is if we have the square root of 5 times the square root of 3, we could write that using this property as the square root of 15. So the two square roots, when multiplied, allow you to bring it under a single square root by multiplying the insides. If you have numbers in front of them, so say 2 times the square root of 5 times 5 times the square root of 6, then you're going to multiply the outsides together because they aren't involved with the square root. So 2 times 5 is 10, and you would multiply using the square root multiplication rule over here, the 5 and the 6 that are inside to get square root of 30. So your final answer would be 10 times the square root of 30. For adding and subtracting square root expressions, the idea is to collect like terms. And what do I mean by a like term with square roots? Well, a like term would be a term that has exactly the same square root in it. So for instance, 2 times the square root of 3 and say 5 times the square root of 3. If I had an addition with these two square roots expressions, I could add them because the square root of 3 is the same in both of them. And just like if we had 2x plus 5x, I could add those and get 7x, so the x stays the same. That's what we do with square roots when we're adding them. 2 plus 5 is 7, and we keep the common square root of 3. So it's very similar to how we would add polynomials. If there was a subtraction in between them instead of addition, we just subtract the coefficients. So let's look at some examples. Number 1, 12 times the square root of 6 plus 7 times the square root of 6. So we have an addition here. What we want to do is add if we have like terms, and we do. We have the square root of 6 twice, so we are going to add the coefficients. 12 plus 7 is 19, and we'll keep the square root of 6. You do not change the square root of 6 when you add or subtract with like terms. In the next example, we have the same two terms but subtracted. So we subtract the coefficients to get 5, and we keep the square root of 6. So you keep that common factor when you add or subtract. Now in the next example, we have three terms. We have 3 square root of 7 plus 8 square root of 3 minus 12 square root of 7. In this example, the square root of 7 terms are like, but they're not like to the square root of 3 term. So we can add those two that I've circled to get negative 9 square root 7. So I said add. You can think about adding them with 3 being positive, negative 12 being negative, or you could also think about subtracting. And then the last term is just a separate term unto itself, so we'd say plus 8 square root 3. So there's some examples of adding and subtracting and simplifying using the rules for collecting like root terms. Here's a few more. In these examples, 4, 5, and 6, we don't necessarily see that these are like terms right away. But what we can do is think about always whether we can simplify any of the roots. So for instance, the square root of 18, if we were to factor the 18, I would have 2 times 3 times 3, or 2 times 9. I still have that 5 square root 2. Square root 2 is as simple as we can make it. But when we look at this first square root 18, the 3's are going to come out basically because they're square root of 9. Square root of 9 is 3, and so we'll get 3 times the square root of 2 plus 5 square root 2. Now that we've simplified that root, we can see that they are like terms, and we can add the coefficients and keep the square root of term that's common. Here's another example. The square root of 90 could be simplified. It again has a 9 in it. So if I pull that out, I'll write this the other way of simplifying this time. 9 times 10 plus 3, and 250 also has a 25 in common. or as a factor, 25 times 10. So we have a perfect square in both cases. You can think about 9 as 3 times 3 if you like pairs for simplifying, and 25 as 5 times 5. When we simplify that, we're going to get 2 times the square root of 9 is 3. The square root of 10 won't simplify, so it stays the square root of 10. 3 times square root of 25 is 5. Keep the square root of 10 underneath there. Continue to simplify. We get 6 times the square root of 10 plus 15 times the square root of 10. And now you see that they really were like terms just in disguise. So we can add the coefficients and keep the common root. So we get 21 times the square root of 10. One more example similar to this. The square root of 20 has a 4 in it. 4 times 5. 4 is a perfect square. We're going to be able to take that out. And then 45 has 9 times 5. So again, we have two perfect squares that we can simplify out. When we do that, we get 2 times square root of 4 is 2 times the square root of 5 stays underneath, minus square root of 9 is 3 times the square root of 5. So we end up with 4 square root of 5 minus 3 square root of 5. And that would be 4 minus 3 is 1 square root of 5. Now technically 1 times anything is just that thing, so we usually don't write this 1. We just write square root of 5. So sometimes like terms won't appear like they're like terms at first. You have to simplify to see that they're like terms so that you can add or subtract them. The next three examples have to do with multiplication, and they're very similar to what we might have seen with polynomials. If we have like for instance in a polynomial, if we had 2x times say 3x plus 5, if we have something outside of the parentheses, we would distribute it to the addition or subtraction inside the parentheses. That's exactly what's going on here. The square root of 7 is distributing into the addition that's in the parentheses. So we're going to treat it very similarly how we would do this with a polynomial. Sorry, the erasing feature isn't very good in this program. All right, I think that's hopefully good enough for what we're going to look at. So let's distribute that. So we're going to get the square root of 7 times the square root of 6. Remember, the rule with multiplication is that you multiply inside. 7 times 6 is 42. Then we're going to add to that square root of 7 times the square root of 2, which is the square root of 14. Now, take a look at those and think about whether they have any perfect square factors in them. If you want, you could do a little factor tree to see that and look for pairs. If you do it though, you won't see any perfect squares in either 42 or 14. So because they're not the same type of root, we can't add them together. That would be simplified. In our next example, we're going to distribute the square root of 2. So we'll get square root of 2 times 3 times the square root of 5. Remember, only multiply things that are on either outside or things that are inside. Technically, there's a 1 out here in front, so we just get 1 times 3 or just 3, and then the inside, 2 times 5 would be 10. Minus, the outsides are just 1, the inside, 2 times 3 is 6. Once again, ask yourself, does 10 have a perfect square in it? Does 6 have a perfect square? In neither case, are they going to have anything? You can't take 4 into 10 or 4 into 6. So this would be the final result because these are not like terms. Our next example, we're going to take 4 and distribute it. When you distribute 4, 4 is on the outside of the radical, so you're going to multiply 4 by anything on the outside. So 4 times 2 is on the outside, so we would say that's 8. There's nothing on the inside of a square root for 4, so we would just have square root 5. Plus, 4 is on the outside, square root of 7, 7's on the inside. They are separate, so all you can do is just show them multiplied together. Once again, the square root of 5 and the square root of 7 are not like terms, so we can't combine them. In these next three examples, what we have are binomials multiplied together. And if you want to recall from polynomials, when we have a binomial like a plus 3 times another binomial like a plus 4, we're going to FOIL. We're going to do the first terms, so a squared, and then the outside terms 4a, the inside terms 3a, and the last terms 12. And then if we can, simplify. So that's how we would tackle a binomial times a binomial. We're going to do the same thing with these three problems with roots. So in this first example, if we think FOIL, we're going to have the first terms. That's 3 times 4, or 12. Then we'll go to the outside, 3 times the square root of 2. Now 3 is on the outside, square root of 2 is on the inside, so all you can do is multiply them, showing them directly like that. The inside, 5 times the square root of 2, and 4. 4 and 5 are both in the outside, so you can multiply them to get the 20. The square root of 2 stays. And then the final thing would be the last terms, 5 times the square root of 2 times the square root of 2. 5 is on the outside, and the square root of 2's are on the inside, so you multiply them together to get the square root of 4. Now let's see what we can simplify here. The 12 is calculated. Now 3 square root of 2 and 20 square root of 2 are like terms, so we can make that 23 square root of 2. Then we have 5, and then the square root of 4 is a perfect square. Square root of 4 is just 2. So we actually have a calculation we can do here. 5 times 2 is 10. So let's write that down with the rest of it. And then 12 and 10 can be added as like terms. So we get 22 plus 23 square root of 2 as our final answer. You can't simplify these two terms any further because the 22 doesn't have a root, whereas 23 has the square root of 2 attached. So these are not like. It's kind of like saying 22 plus 23x. Those are not like terms. You can't combine them. Same thing with this 22 plus 23 times the square root of 2. They're not like, so you can't combine them. In the next example, we'll do the same thing. First terms, square root of 5 times the square root of 5 is the square root of 25. Outside terms, it's a minus square root of 5 times the square root of 6, so that's square root of 30. The inside terms, plus square root of 6 times the square root of 5 is the square root of 30. And then finally, a positive times a negative would be a negative square root of 36, because 6 times 6 is 36. Now when we look at that, we have two terms in the middle that basically add to 0. They're going to go away. The outside terms actually simplify. The square root of 25 is 5. The square root of 36 is 6, and so we get a really nice simplified answer here of -1. Why did that happen? Well, if we go back to the original problem, if you look carefully, these were conjugates. Remember, we talked about conjugates with polynomials. Conjugates are when you have the same two terms with a sign change multiplied each other. So square root of 5 plus square root of 6 times square root of 5 minus square root of 6. The only difference there is the sign in between. And when you multiply conjugates, you have this nice feature that the middle is going to add up to 0, so you'll only get the outsides coming out, the first and the last, when you FOIL. And in this case, with square roots, something really nice happens. The square root goes away entirely. We're going to take advantage of that relationship later when we're working with division with square root expressions. In my last example, we have a binomial, in essence, kind of, squared. Square root of 5 plus 3 squared. Remember, when you square a binomial, you're just multiplying it by itself. So we get the square root of 5 plus 3 times the square root of 5 plus 3. FOIL that out. The square root of 5 times 5 is 25, plus the outside, the 3 is on the outside, the square root of 5 is on the inside. The inside terms, same thing. And last terms, 3 times 3 is 9. Simplifying, the square root of 25 is 5. 3 times the square root of 5 plus 3 times the square root of 5, those are like terms, so we can add them. 3 plus 3 is 6, but you keep the common square root of 5, plus 9. And then 5 plus 9 is 14, plus the square root of 14 plus 6 times the square root of 5. So those are the examples. Hope that helps.